Hello. So this problem is wants us to calculate a Fibonacci number, and if you like, you can go to this site here on Wikipedia and look that up. And essentially, what we're going to be doing is making a loop that continues to add the previous two numbers to its to a total. So we're going to do this a step at a time. It takes a little bit of thinking about, but it's a good example of the kinds of thinking that you need to be able to do when you're programming. As a little extra, I have in here displayed the numbers in rows of 7 across, and each of them being 5 characters wide, and run an empty program to see what the output looks like. In addition, I've given you the main, so that all we really have to do is focus on writing the function. So let's close that up, and I should have that on it, and so there that is. Okay, now you can't, if you run this, of course it's not going to compile because you don't have that stuff at the top that you need. So so that's not a good way to start. So let's just start grabbing the parts that we do need, that we always know about. Pound include, IOString. Probably won't need string for this one. So there's that. Now we're also calling this Fibonacci function, so I'm just going to comment that out for right now. See if that gets us any further along. Here we go. Okay, so let's see what the output here was. So we got please enter a number 5, and Fibonacci of 5 is 0. Well, if you look here, we can see please enter a number 5, but then we're supposed to display these numbers, and the Fibonacci 5, the fifth Fibonacci number is 5, not 0. But that's how, as we would expect. By the way, in that link that I sent you, or I should say gave you with the problem, here is what the page looks like, and included in that down here is a list of the first 20 Fibonacci numbers. So what we're looking at here is simply we start with 0 and 1, and we add these two together and we get the next number. Then we add the previous two together to get this number, then the previous two to get this number, etc. So this will give us a reference point for going back and forth with this problem. Let me get back to my vocariums. There we go. Here we go. So so if we look back at this code, we can see obviously it's not working right yet. So let's do this. Let's put some temporary output here. Now we can tell here that fib is on the left-hand side of the call to Fibonacci, and fib is an integer. So therefore, the Fibonacci function is going to be of type integer or int. And it's also accepting some value, which is here called num. And just to demonstrate that it's not necessary that it be called num, I'm going to call it x here. And then I'm going to return 5. Now 5, obviously we're not calculating anything, but let's just see what happens when we run this. So if test 1 still failed, but if we look at the output, we can see Fibonacci 5 of 5 is 5, or the fifth Fibonacci number. So so that's just because we faked the value right here. This, of course, is called hard coding, and you cannot submit your programs with this kind of hard coding. But it's a good way to get yourself started to make sure, okay, well, whatever's going on here, you know, let me move a little step ahead and a little step ahead and see, you know, if we can move in, as I'm saying, in small steps here and get something rolling rather than just try to write everything all at once and then have it not working. So the next thing is that we have some kind of a loop here. So let's just call it, this loop control variable we're going to call count, and we're going to set it to 0. And we're just going to say this: while count is less than x, we're going to do something. Well, what's that something? Well, at a minimum, we better make sure that we add 1 to count. Right now, we can do that with count plus plus, or if that's still confusing to you, it would be count is equal to count plus 1, right? So either way, but we'll leave it in the in this plus plus format. So if nothing else, this will end at some point, right? As long as x isn't, well, in fact, it'll end if x is negative also, just won't execute. So so at any rate, so that's that. Now let's see what else can we do here. Let's just see out count and maybe a space. And there's not even a an end L here. And let's just, well, just to make it look a little nicer, let's just put an end L here. Okay, so we'll run that. All right, let's look at the output. So we got 0, 1, 2, 3, 4, right? And that makes sense because the number we put in there is 5. Of course, we're not just trying to count numbers, we're trying to keep the previous value, 2 previous values, and add them together to get us the next value. But it starts to give us something that's starting to look like an answer to the problem. So, all right, so what are we going to do here about the more general problem? Keep in mind that the definition says that it's something like this: the next value is equal to the previous plus the current one. So let's just create ourselves a variable called prev for previous, and another one called cur for current. Alright, so if that's the case, we could do something like this. Let's display the previous, and then we're going to say the previous is equal to the, the current is equal to the previous. Right? So in some sense, let's see if I can put a little text up here for you. So if we have a 0, that's the previous, and a 1 is the current, then, and the next step, the current is going to be the previous, and the next one is what? Well, the next one then would be the, it's going to be the previous one plus the current one. Now we have to be a little careful of the order here, right? So, in fact, we don't want to do this first. Let's do this way. So now, what's going on here? Well, let's see. So we don't have next defined, so let's define next. And it won't matter what we set it to originally, because the first thing that's going to happen is it's going to get a new value anyway. Right? So the next one is going to be, in this case, 0 plus 1 to begin with. Right? And then the current will be equal to the previous. And let's display next in here. So let's move this one down and put this one here. And let's display next. Okay, so we've assigned a value. There's next. We put a space next to it. Now we're going to say the current is equal to the previous one, and the maybe a little bit clearer about this. So right now we have 0, 1, and then the total, which is 1. So, and it's a little hard to see on here, but I'll try it this way. This is previous, this is current, and that's next. So what we want to do is we want to make this value the previous and this value the current. All right, so the previous is equal to the current, and the current is equal to the next. So let's get that one out of there. So here's the situation. That's previous, this is current, and this is next. So then once we're finished, we want it to look like this. All right, so previous will be 1, current will be 1, and then this one has not been defined for the next time through the loop yet. So I'm not sure that this is going to work exactly right, but let's see if it gives us anything usable. Let's make sure that it executed. All right, it did execute. Of course, it's not working right, but let's look here. So what did we get here? 1, 2, 3, 5, 8. Now let's look at the numbers here. 1, 2, 3, 5, 8. Oh, that's pretty good. Right, we've done all right here, but we're starting on the second, the F2, the Fibonacci 2. That's because we're displaying the next value. So let's go back, and instead of displaying the next value, let's display the previous value. Now let's see what happens. All right, let's look at the output. So now we have 0, 1, 1, 2, 3. So let's take a look here. 0, 0. I'm sorry, did I just say 0 twice? Nope, 0, 1, 1, 2, 3. Here we go. 0, 1, 1, 2, 3. So that's cool. We got that one right to here. All right. Well, now we're actually looking for this one, because if we go back to our program, we are testing this with, oh, you can't tell here. Let's look here. We're testing it with the number 5, right? So this actually, you see, this is working. Although it's not really working because it just happens to be 5 there. So what is it that we want? Let's go back and look at that. Look at that. We have these two numbers right here, and this is a number we want. Well, guess what? So if we come back here and do something like this, we can return prev plus cur. So let's see if that just happens to come out with the right number. Okay, so that's not coming out with the right number. So now this is because, although we're seeing these up here, this is always the prev values, right? That's what we're displaying here, right? So now let's do this. I'm just trying to think of how we can display this so that you can see it. Let's do this. Well, I'll tell you what, why don't we just display or return prev here? Start with that. As I don't believe that that's going to work, but let's just give it a check. Oh, well, let's see. Oh, it did work. Okay, there we go. So return prev here gave us a number we wanted. So that's cool. All right, so now we don't know. We'll have to check to see if it always gives us the number we want. But we're certainly getting along there. Now, it looks to me like if you look at this, we have the right numbers, but for some reason there's spaces all through them. Well, that's because of the part of the problem that said that all the numbers should be displayed in a width of 5. Well, that's easy enough to do. you in C++, you just do this. That just sets the width to 5 right in front of whatever it is you're trying to display. So let's just see if that gives us what we want. All right, let's see. Uh-oh, something didn't work. Let's go back and look here. Whenever you see this, that means something is not compiled, and here it is, set W is not defined in the scope of this usage. Well, okay, I said it was easy, but I forgot that we have to have this header file in there, so let's pop that in there. Pretty sure IO manip is the one we want. Let's see if it works out. No, it is not IO manip. Well, isn't that interesting? Okay, that just turned out to be a slowness in the save feature from Vocarium. So it actually is IO manip. And if you look on, I'm going to try to get this so that I can just drag it without extending it to the whole screen. If you look on the reference card that you're going to be given for the exam, you can see here IO manip is right here, and there's the set W. So in case you were to forget that, then you'd be able to look it up, right? Because nobody can remember everything. You know, what you need to remember is how to program, and if once in a while you have to look up something, that's not that big a deal. Now, that doesn't mean looking up entire solutions. It just means looking up things like what header file goes with set W. So here's the current output from the program. Let's just catch back up with what we're doing. We put set W5 here, and we did that so that it would force everything to a width of 5. And so let's see what we're missing here. Probably it's because of this extra carriage or line feed here, endl, that I put in here. So let's just take that out of there, and let's see what else, how far we've gotten. Okay, so this first one passed, and that's good. And if we look at this, we go, okay, that's great. Here we go. Now, the issue with the second one is that if you look at the differences here, this is what our program creates, and this is what it's expecting. And if you remember way back when I read the instructions out loud here, or showed you, it said display numbers in rows of 7 numbers across, each 5 characters wide. Well, we've handled the 5 characters wide, but we have not handled the 7 characters across. So let's take a look at how we're going to do that. So let me just get these out of here because those were just explanatory. And now the question is, how do we have this display every 7th answer? Well, what does 7 mean? 7 here means this is, I'm sorry if that sounded choppy. I got interrupted, so I'm backed up a little bit here. Okay, so anyway, so we're trying to get every seventh one of these. Well, what does that mean? Well, we know about the modulus operator, and we've used it for even and odd. That's, you know, basically 0 and 1. When you divide by something, the remainder is either 0 or 1. Well, you can use this for other purposes. This count value is going to start at 0, and it'll be 0, 1, 2, 3, 4, etc. And the question then is, well, how about if we just say something like this? If count mod 7 is equal to 0, then we're going to see out an end line here. Now, that might not get it exactly right the first time, but let's give it a whirl and see what we've got. Okay, so let's see here. Running test 2. And let's see. All right, right now we are not seeing all of the output, so let me see if I can make this come up here a little bit better. There we go. Okay, all right, so let's look to see what we have going here, because I think we're having a little bit of issue here with the display. I'm going to grab all this and I'm going to copy it in case I lose it here in this next step, and I'm just going to refresh the screen, because it seems to me that I'm not getting the full output. Yep, there's output 2 right there. Okay, so and here's output 1. Okay, now let's see. We have 0, and then all of a sudden 1, 2, 3. And then here we have 10. And so let's go back and look at this. All right, so what's the deal here? So let's do something and force this issue. Let's just say CNT is equal to CNT endo. All right, let's just run that. Now, obviously, it's not going to match. Okay, let's look at the output. Okay, so first of all, we have this extra NL here. All right, so that's a little disconcerting, and I know what it is, but we'll go back and fix that in a minute. Let's see what this one is here. I believe that one's still left over from before. So let's see. Yeah, that one's left over from before. You can tell because it doesn't have the CNTs anymore. All right, so this is really not going to help us except for this first carriage return here. So that's not going to help us much. So let's get rid of this, and let's figure out why we have an extra endel. Well, if count is 0, 0 mod 7 is going to be 0. So right off the bat, it's going to give us an extra carriage return. So let's put this after that and see if that gets us any further along. Oh, all of a sudden everything passed. Wow, that's pretty cool. So let's take a look. So here we have, we've already done this one to death. So let's look at this one, right? We have 1, 2, 3, 4, 5, 6, 7, and then 3 more. That makes up the 10. Now this, if we go back and look, Fibonacci of 10 is 55. And that's correct. Now notice though that this is starting at 0. So it could be a little disconcerting because you'd say, well, wait a minute, there's 10 of them up there. But this is actually the 11th entry, Fibonacci of 10, because it starts at 0. So let's look at this one, and that has groups of 7, and it says 15 is 6, 10. Let's go back and check. There it is. And last one here is 20, and we have groups here of 7, and 20 is 67, 65, and that matches the one from our reference point. So all of a sudden it just worked, and when it worked for all of them, right? And so the way that I just described solving problems is the way that you actually do it. And sometimes students think that they should magically know exactly what to type from the top down in one swoop and then run it and it'll be perfect, and they go on to the next one, and it just does not work that way. You have to practice solving the problem by doing it step at a time and doing what I just did here, and when going, okay, well, wait a minute, that's not working. Oh, why isn't this working? Okay, let's check that out. And you just keep at it until it does, until the program does what you need it to do. And so there's a sense of perseverance on this, and there's really no substitute for that. And the more you practice, the better you get at it.